All right, this is classwork 10.12, writing exponential equations from graphs. It is another three-pager today, so it is another big one, but we'll get through it all. So today your team will develop a method for finding an equation from a graph. As you find ways to write equations based on a graph, you'll build a deeper understanding of exponential functions. All right, most of the exponential equations you have used in this chapter have been in the form y equals a times b to the x. What does the a represent in the equation? If you remember, the a represents the initial value, but it also, we found out yesterday, represents something additionally to that, and that would be that it is the y-intercept. Okay. And then b, what does the b represent in the equation? The b is going to represent our growth ratio. All right, let's go on to number 2 then. Use your graph and your pattern detection skills to complete the table and write an equation. Okay, so we're only given the graph. We have to come up with the table, then we have to come up with the equation. This is actually pretty simple. So you guys are good going from a table to an equation. That's nothing new. So now we just got to put in the initial step of going from the graph to the table. And we've got some nice dots here to help us with that. So we've got a point when x is 0, it's 1. When x is 1, we've got 3. And when x is 2, we go all the way up to 9. Okay, so these are the only dots we're given. We can't look at 3 on the graph, and we can try and look at -1, -2, and so on, but it's really hard to see exactly what those decimals are. So I would say that we're only able to come up with these 3 points from the graph. But luckily, that's all we need. Hopefully you guys can see a pattern. How do we get... Well, first of all, we need 2 things. We need our initial value, and we need the growth ratio in order to write the equation. Okay. So what is my initial value? We can see that is going to be 0, 1. So my a value is going to be 1. And then it'll be 1 times b to the x. The next thing we just have to find out is what's the growth ratio. So how do I get from 1 to 3? Hopefully by now you know that we're kind of looking for a multiplier. So in this case, how can I multiply to get 1 to 3? And that'd be times 3. If you're not sure of that, or if you can't do that in your head, remember you can always do 3 divided by 1 to figure out what that number is. And then we just want to double check to make sure that works. If we keep going, 3 times 3 is also 9, so that is perfect. So our growth ratio is 3. So my equation is y equals 1 times 3 to the x. So let's continue our table. 9 times 3 is going to be 27. And then if I keep filling out my table, 27 times 3, that equals 81. Perfect. And then we've got to go back 1 here, so -1. Remember, if we're going to go backwards, we're not going to times by 3, but rather divide by 3. So 1 divided by 3, you can put that in your calculator if you need to, or it is just 1/3, so 0.33 repeating. Notice this equation, we don't actually need the 1 here, so if you gave me the equation y equals 3 to the x, I would also take that, but it's totally okay if you want to put the 1 there. And last part for number 2, it says check your equation to find the value of the exponential function at x equals 3. Does your answer match the value you found for x equals 3 in the table? So if we want to plug that in, we need to plug in our equation, which is going to be 1 parenthesis 3 parenthesis, and then we want to check for 3, so to the third. And our hope is that this number is 27, and in fact it is, so we are correct. A couple other ways you could have done this one if you wanted to. You could have went to your y equals, and you could have plugged in the equation y to the third to the x. and then looked at the table, and then gotten your table from there also. So if that's the way you want to do it, that's perfectly okay. So does your answer match it? Yes, it does. It checks out. All right, go ahead and go on to number 3.